This is a Bearcat 210 scanner, radio scanner. It's a survivor of a dumpster. I don't know if it works or not. Somebody threw it out, so I'm assuming it's got some problems. I was able to find a service manual on the repeater builder, and so I have schematics and some board diagrams and that, so I should be able to fix this barring any unobtainable parts, which can happen. So let me switch it on and see what happens. Well, that's a good sign. I'm going to put a, let's see, I'm going to enter a frequency. Let's try. .0. I got a handy talkie. Well, the pots are dirty. 1, 2 test. That doesn't sound good. Anyway, it looks like it needs some work. I see why it landed in the dumpster, so I'm going to take it apart and do some tests on it, and let's see if we can fix this thing. These actually are nice to monitor if you're fixing something. You can use it as actually a test equipment to test the output of a transmitter. You can listen in on it, so they still have some utility. Here's a look on the inside here, main PC board. Nothing looks out of the ordinary on a cursory look here. Here's the main filter cap. I'll check that. Here's the other side of the board. There's some near the antenna receptacle, there's some dust or something. This is kind of a bodge. And the solder joints don't look very good either, so I don't know what that's about. One thing I noticed, the battery backup here is all corroded. It had a little battery in it, leaked, which is normal for these old things. So I'll clean that off and put a new battery in, and maybe at least the memory might work then. I did a little fader lube in the pots here. They were pretty nasty, so that should clean up the scratchiness of the pots. Other than that, it's not too bad a shape. These are going back a few years. I remember these back in the 80s sometime. Not sure when this one was made. Yeah, I don't see a year right off. I would say it's probably in the 80s, early 80s maybe. Just looking at the construction. To a bench power supply. Pulling about 250 mils, which is about right. It's still got an awful noise in it.
1, 2, test, 1, 2.
I can hear my audio.
Hello, test, hello, test.
So it sounds like the receiver's working, but we've got an awful noise in the background there, so I'll have to investigate that. So it might be a problem with the power supply, along with some other things, we'll see. Anyway, I'll go through it and see what we find. Back on the AC power supply here.
1, 2, 3.
I can't really see much difference between a pure DC from a bench power supply and the internal AC supply.
Testing 1, 2, 3. 1, 2, 3, test 1, 2, 3.
I'm running a signal in from a service monitor about a little over 3 microvolts, 3 or 4 microvolts. And I'm getting a lot of noise here. That doesn't sound good. I think the first thing I'll do is I'm going to check the power supply and see if we got some ripple on here. I've got the scope across the input filter capacitor, and I'm getting some ripple here, which is normal because this is pre-regulator here. So now I'm going to go to the output of the regulator. Looking on the schematic here, here's the regulator transistor here. Uses a LM358 dual op amp for in your feedback here for your comparator for your regulator, which is kind of strange. You'd think they'd use a 3-terminal regulator since this was made, I believe it's 1980. Anyway, the output here would be on the collector of, let's see, Q8, I believe it is. Yeah. And Q8 is this transistor here, and the collector is the center pin, which is, if I do this without shorting it, and there's the scope. There, it's off the lead, and here's the collector. So power supply looks good, so the problem is not the power supply. I'm going to connect a signal from a service monitor directly to the input here. Maybe. Find a ground. That doesn't sound good. Almost sounds like a bad solder joiner connection. Oop, what happened? It doesn't sound good. Oh boy. Okay. Well, that doesn't look good. This is get the schematic. Okay, this is IC1 here. IC1. And that is, looks like it's in the front end here. Yeah, IC1 here. RF comes in. Here's your two inputs here for your high and low band. IC1 RF amplifier VCO. Oh boy, that's going to be a tough one. And wonder what that is. Probably unobtainable. I think what I'm going to do, I'm going to try resoldering here. I may have a bad solder joint on this chip. It seems to be kind of fussy when I tap it. So let's see what the back. I'm going to turn it off here. Power it down. And here's that chip here. Boy, there's a lot of bodges in here. I don't know if this was done later. I mean, you got this little array, star array here. You got a bunch of parts tacked on here and there. Here's a choke and a cap in series with an insulator under it from this chip to here. I don't know what that's about. Maybe somebody modified this for some ham project. Here's where your RF comes in here. Your antenna comes through the case and screws into this again. Anyway, oh boy, I got a couple joints here that look kind of funny. That's a problem with these old radios. A lot of the solder joints go bad, and then you get intermittents like this. I'm going to resolder this chip, and then I'm going to see if we get any effect. Yeah, I bet you I wouldn't be able to find one of these anywhere. Some of the other ICs, you know, I can replace, but there's always a specialized IC that you can't obtain. So I'm going to do that, and then I will test it again. We'll see what we get. Stand by. I soldered all the connections on the chip, the RF amp VCO chip, and I saw a couple others I touched up. This cap looks good. I tested that, the main filter cap. There's a number of other electrolytics in here. I'm not going to replace them because they might not need it, but I am, I think I've got that problem. Seems to be solved here. Anyway, I'm running in about 7 microvolts. There's a little bit of noise on there. Let's give it a real test. I've got my trusty HTX 404 445.0. Let's give it a test with that.
Test 1 2 test 1 2 test. Hello test.
Well, that seems to be working here. The display seems a little dim, maybe not too bad. This doesn't have a dim switch on it. Anyway, let's hit scan.
Test 1 2 test.
Oops. Never say oops.
Test 1 2 test 1 2.
Well, that seems to work.
1 2 test.
Well, I think that's boy, I don't know. There's, looking at the bottom of this board, there's an awful lot of bodges under there. I'm going to clean it up a little bit. Clean some of that dirt. Don't grab 120 volts. Don't want to do that. You know what that does. Not good. Anyway, I'm going to put it back in the case, and that shielding will probably help a little bit. And then I'll give it another quick test here, and we'll see what happens. I modified this scanner for the memory backup. On the original scanner they had this little jack, which was on the outside, and you put a screwdriver in, pull this out, and then you could insert one of these little button cells here. I didn't have any of those, and I didn't like the arrangement of this. Plus, this thing was so corroded. I cleaned it, but I had a feeling the contacts wouldn't be very dependable. So I added a AAA alkaline battery holder here. I just used contact cement to the back. When I removed this part, it left a big hole, so I just put a grommet in there to protect the wire. And then those two wires for the memory backup come back here, the green and the orange here. And this way I don't have to take the unit apart. I can just pop a battery out, put a new one in. Supposedly it'll hold the memory for a short time when you change batteries. I don't know. I don't really care about that, but this will be a lot easier and a lot more convenient than trying to find one of these little button cells. Anyway, that's just a modification you might want to think about doing if you have one of these. Alright, there's 7 microvolts running, and I'm going to crank up the gain a little bit. There's 13, and there's 20 microvolts. Yeah, it seems to lack a little sensitivity. I'm going to run up some more. There's 50 microvolts. Yeah.
Test 1 2 3 test 1 2 3. Hello. 1 2 3 test.
Okay, I think it's working. I am going to go through the alignment of this thing. I do have the service manual for this thing. I found it on Repeater Builder page, so it's got alignment instructions and a parts list. Anyway, back to that RF VCO chip, which is a specialized integrated circuit here. Where was it? IC1 NC57801. It's a custom chip. Now I put that in the internet. I just got one hit, and it was G&G Communications, and apparently they've got one of these. I imagine it costs a fortune, but luckily this one was okay. It just needed had a bad soldering joint on a couple of the pins. Looked bad. One was really bad, so that seemed to. It's a Electra part number NC57-801. Anyway, these are fairly easy to fix unless you get a part, one of the parts that are, you know, no longer made, hard to find. So the display seems a little dim too. I might look into that. It's not, well, I guess not too bad. In direct sunlight it's hard to see. Anyway, about the old gal back to life. So if you get one of these, the schematic's available, the service manual's available. Good luck. Hope you can fix yours, and thanks for watching, and we'll see you in the next one. Bye for now.